Assalamualaikum warahmatullah. This is Muhammad Akramuzzaman Onto from Elevare, and I'm your IGCSE Physics instructor. Today I will be going through the November 2025 Physics Paper 2, and as your exams are approaching, I have decided to solve this paper so that this solving video helps you on your exam day. So without any further ado, let's begin. Alright, the first question says that the diagram shows the apparatus used to investigate electric charge. Okay, the equipment is viewed from above. Let's have a look at the equipment. Okay, so this is mainly the equipment. As we can see, we have got two balls over here, ball 1 and ball 2. One of the balls is basically attached to a rod, and the rod is attached to a point P. Okay, let's read the rest of the question. The equipment is viewed from above. Ball 1 and ball 2 have got a positive charge. Okay, there's another information. Ball 1 and ball 2 are positively charged. Ball 1 is fixed in place. Ball 2 is attached to a rod that can rotate about point P. So ball 2 is mainly attached to a rod, and this rod can rotate about point P. This rod can rotate about point P, which basically means that this rod can either move in the clockwise direction, in the clockwise direction or in the anti-clockwise direction. It can mainly rotate around point P. Okay, ball 2 does not move, which means ball 2 is stationary. And as we can see, there is a spring here as well. Okay, now the first question asks, state in terms of charged particles how the balls have become positively charged. Okay, they have asked how the balls have become positively charged. Any object is neutral because they have got equal number of protons and equal number of electrons. Because we know that protons are positively charged and electrons are negatively charged. When there are equal number of protons and equal number of electrons, we have got equal number of positive and negative charges, and hence objects are neutral. Now, in order to make an object positively charged, it needs to have more number of protons and fewer number of electrons. So the balls can only become positively charged when it loses electrons, right? And hence the answer to the first question would be just by losing electrons. All right, we normally do so by using an insulator, and we rub that insulator against the ball. That's when the ball loses electrons. For example, we use an woolen cloth in order to rub the ball against, and when we do so, the ball loses electrons and it becomes positively charged. Okay. The next question is, ball 1 exerts a force of 0.57 Newton on ball 2. State the value of the force exerted on ball 1 from ball 2. So ball 1 basically exerts a force of 0.57 Newton on ball 2. Now we have been asked the magnitude of the force that ball 2 exerts on ball 1. So here we have got the ball 1. It basically exerts a force of 0.57 Newton on ball 2. This F is 0.57 Newton. Now, according to Newton's third law, the ball 2 is also going to exert an equal magnitude of force on ball 1 in the opposite direction, which is 0.57 Newton as well. We know that Newton's third law states forces, every force has an equal and opposite reaction. So if ball 1 exerts a force of 0.57 Newton on ball 2 downwards, then obviously ball 2 is going to exert an equal amount of force on ball 1 upwards. And the forces are going to be repulsive because both of them are positively charged. All right. So the answer to this question would be 0.57 Newton. Calculate the moment on the rod from force F about point P. We will have to calculate the moment on the rod from force F about point P. We will have to calculate the moment of this force. We will have to calculate the moment of this force with respect to this point. We will have to consider this point as a pivot. So this is mainly the pivot, and we will have to calculate the moment of this force, which we will have to calculate the moment that this force creates with respect with this point. Now we know the formula for moment is force into perpendicular distance from pivot. That's basically the formula for moment, force into perpendicular distance from pivot. So here's the direction of this force, and this direction of this force is mainly perpendicular to this distance or to this length, which means we will have to multiply 0.57 with 4.2 in order to calculate our moment. We will have to make sure that the direction of this force is basically perpendicular to the direction of the pivot or to the plane of the pivot. So 0.57, which is the force over here acting in this point in this direction, which is vertically downwards, is mainly perpendicular with this horizontal distance, which is 4.2. And hence we will have to multiply 0.57 with 4.2 in order to calculate the moment. Interesting thing over here is that they told us to calculate the moment in terms of Newton centimeter, and hence we didn't have to convert this distance or this length into meters. That means we didn't have to divide it by 100. All right. Moving ahead, we have got the next question, which is state the magnitude of the moment about point P due to the force from the spring. So they have labeled the direction of the force from the spring, which is mainly upwards. And now they have asked us what would be the moment of this force with respect to this pivot. Well, that is going to be equal to the moment that this force creates. Because since the system is in equilibrium, we know that when the system is in equilibrium, at that time sum of clockwise moments is equal to sum of anti-clockwise moments. This force over here basically creates an anti-clockwise moment with respect to P, and this force over here basically creates a clockwise moment with respect to P. So if we calculate the anti-clockwise moment, which we did in the previous question, that would be equivalent to the clockwise moment created by this force on the spring with respect to this pivot. So the answer to the previous question would be the answer to this one as well, which is 2.394 Newton centimeter. Last question, draw an arrow on the diagram to show the direction of the force that the rod exerts on the spring. So we will have to draw an arrow on the diagram to show the direction of the force that the rod exerts on the spring. We know that the spring exerts a force on the rod in the upward direction, and hence the rod would also exert an equal force on the spring downwards. So I just drew the arrow downwards. I had to point it downwards because the direction of this force is obviously downwards, and I clearly started drawing the arrow from the spring because this force is being exerted on the spring, and I tried to make sure that the length of this arrow is equivalent to the length of this arrow as well, because both of these forces are equal and opposite. Hopefully you have understood this question. If you have any difficulties in understanding any parts of this question, then do not hesitate to write in the comment section. All right, let's have a look at the next question. This question is about gravitational field strength. The table shows the gravitational field strength of the surface of 4 different planets. The planets have the same mass but different diameters. Okay, so we have been provided with the diameters of some planets and their corresponding gravitational field strength. Okay, give a reason why scatter graph is the correct way to display this data rather than a bar chart. If you carefully look at the data provided over here, these data are basically continuous data. These data are not discrete data. If discrete data were used, then we would have to represent those information or those data by using a bar chart. But you can clearly see over here that these information are continuous rather than being discrete. Bar chart is only used for discrete data. Scatter graphs are mainly used for continuous data. And hence that would be the answer to this question. Both the diameter and gravitational field strength are continuous variables. Okay, moving ahead. Student claims that the relationship between the gravitational field strength and the diameter of a planet is given by this formula: gravitational field strength times diameter squared is equal to constant. Using data from the table given in the student's claim. These types of questions are very simple because you just have to use the data from the table, and you will have to make sure that the calculation that you do using the relationship that has been provided gives you a constant value. So what you have to do in this type of questions, I have provided some tips over here. Calculate at least two constants using the values from the table in this type of question. If the values are close enough, consider that the claim is valid or else invalid. So you just use the information from the data. For example, you choose the first set and the second set, or you can choose any two sets. You can choose the first one and the last one, the last two ones, or the middle two ones. So let's choose the first one and the second one. You use these two sets of data, and then you basically apply them onto this particular relationship and check whether that gives you a constant value or not. That's what I've done over here. I just chose the first two sets of data, and then I just used this relationship. I calculated the values, and I realized that these values are almost close to each other. And from that observation, I concluded that the claim is valid. So always remember to calculate at least two constant values. If you calculate one, you won't score full marks over here. You will have to make sure that you basically calculate at least 2. You can go for more as well, but it's better if you just calculate 2 because your time is really, really important and limited. All right, let's move on to the next question. The diameter of a planet affects the gravitational field strength at the surface of the planet. Which of these is also a factor that affects gravitational field strength? Mass, right. Mass is mainly another factor which basically affects the gravitational field strength. Absolute magnitude does not affect the gravitational field strength. Color has got no connection with gravitational field strength. Specific heat capacity also has got no connection with gravitational field strength, but mass has got uh, some relationships with gravitational field strength. Mass is mainly directly connected to gravitational field strength. The heavier the mass, the greater the mass, the stronger the gravitational field strength. All right, so I hope you have understood the second question as well. All right, let's move to the next question, which is question number 3. Let's see what we have over here. The diagram shows some of the parts of a hydroelectric power station. So this is mainly the diagram of a hydroelectric power station. This is mainly the planning for a hydroelectric power station. We can see that we have got a dam over here. Water flows through the dam, goes all the way over here, and it runs through the turbine. And the turbine rotates, generating electricity over here. All right. Okay. Water enters the turbine with a momentum of 120,000 kg meters per second. State the formula linking momentum, mass, and velocity. So we all know about it, and we will obviously have to keep this one memorized, which is momentum is equals to mass times velocity. A mass of 14,000 kg of water enters the turbine. Calculate the velocity of the water as it enters the turbine. So we know the momentum of water as it enters the turbine, which is 120,000 kg meters per second. We also know the mass of the water that enters the turbine. We have been asked to calculate the velocity. So we just substitute these values over here. We substitute the momentum over here. We substitute the mass over here. And then we just make velocity the subject in order to calculate the velocity of the water as it enters the turbine. So that would be 8.6 meters per second. Make sure you write the answer to this question to two significant figures because the figures used are in two significant figures. All right. Let's move to the next question. The 14,000 kg of water leaves the turbine. This water has a momentum of 63,000 kg meters per second after it leaves the turbine. The turbine exerts a force of 61,000 Newton on the water. Calculate the time taken for the water to pass through the turbine. Okay, now the 14,000 kg of water leaves the turbine with a momentum of 63,000 kg meters per second. So when it enters the turbine, it enters with a momentum of 120,000, and when it leaves, it basically leaves with a momentum of 63,000. So in between entering and leaving, there is a change in momentum, and this change in momentum basically causes the water to exert a resultant force on the turbine, and the turbine also exerts a force on the water as well. Now we know that according to Newton's second law, resultant force is directly proportional to the rate of change of momentum. If we write that using an equation, that would look something like this. Resonant force is equal to change in momentum over time. So we can easily calculate the change in momentum because we know that the momentum when the water was entering the turbine was 120,000 and the momentum of water as it left was 63,000. We can calculate the difference between these two values, which would be like final momentum or initial momentum minus final momentum, because we'll have to keep the magnitude positive. So 120,000 minus 63,000 would be the change in momentum. And we do know the resultant force that is being exerted. So we can place that in our equation. So if we calculate the change in momentum and we place the resultant force over here, we can make time the subject, and that will be the answer to this question, which is 9.3 seconds. All right, I hope you have understood this question. Let's move ahead. Okay, as the water passes through the turbine, energy is lost from the water's kinetic energy stored. Explain what happens to the energy lost from the water's kinetic energy stored. Okay, now in this type of questions, you will always have to remember three key points. First of all, which energy is being transferred, from what object to what, and how it is being transferred. You will have to remember these three key points. If you remember these three key points, and if you structure an answer based on these three key points, you are more likely to score full marks on this type of questions. For example, what I've written over here is that the kinetic energy of the water is transferred to the kinetic energy of the turbine mechanically. Look, I have clearly considered the first point, which is which energy is transferred, the kinetic energy, and to the kinetic energy. From what object to what? The kinetic energy of the water to the kinetic energy of the turbine. So I have clearly mentioned which objects are involved in this energy transfer. I've also included what types of energies are involved in this particular energy transfer, and finally how it is transferred mechanically. Now, some of the kinetic energy of the water is also transferred to the thermal energy of the surroundings. So I have also ensured the first 2 points over here as well. So I have made sure that all these 3 points are present in my answer, because only then I'm going to be scoring 3 out of 3 in this type of question. So you have to make sure that you write which energy is mainly involved in this energy transfer. You will have to make sure which object is mainly involved in this energy transfer. And finally, we will have to write how the energy is being transferred. So if you write these, if you make sure that you have got these 3 key points in your answer, you are more likely to score full marks in this type of questions. And even if this question comes in paper 1, you will also have to tackle in the same way. These types of questions are always answered maintaining the structure. Finally, hydroelectric power is an example of a renewable resource for the generation of electricity. Give 2 examples of non-renewable resources for the generation of electricity. So there are plenty. I have just mentioned 2 over here: coal, natural gas. You can also talk about oil. And yeah, there are other examples of non-renewable energy resources. Okay, so I hope you have understood this question. If you find any difficulties still, then don't forget to write them down in the comment section below. All right, let's look at the fourth question. This question is about sound waves. Describe an investigation to measure the frequency of a sound wave with an oscilloscope. We'll draw a diagram to help your answer. So this is an experimental type question. You should always expect an experimental type question in your paper 2. Okay, in this question, you have been asked to measure the frequency of a sound wave by means of an oscilloscope, and they have told us that we can draw a diagram to help us write our answer. Now, drawing a diagram is not compulsory, but I still brought a diagram from say my exams in order to make you understand about this thing. So as you can see that we have got an oscilloscope over here, which is mainly connected to a microphone, and the microphone is basically placed close to a tuning fork, which is mainly creating the sound waves. Now, the sound waves are detected by the microphone, and the oscilloscope mainly generates the signals, and we can see the signals on the oscilloscope screen. We have got multiple knobs over here, and one of them is obviously the time-based knob, which we will have to deal with. Okay, now let's see how we will carry out this investigation. First step is connect a microphone with the oscilloscope and place it close to the source of the sound wave. Since they didn't tell us what is mainly creating the sound wave, I just wrote source of a sound wave. Okay, adjust the time-based knob to obtain a steady trace which fits in the oscilloscope screen. So one of the knobs is the time-based knob. We're going to adjust the time-based knob so that we can actually adjust the trace that is being presented on the oscilloscope screen. We're going to keep adjusting the time-based knob until we obtain a steady trace which completely fits our oscilloscope screen. After that, we're going to count the number of boxes horizontally for a complete wave. We're going to count the number of boxes horizontally which fits an entire wave, and then we're going to multiply the number of boxes with the time base to obtain a time period. Okay, now in this context, boxes basically represent divisions. So you can also write divisions over here as well. Count the number of divisions horizontally for a complete wave, and then multiply the number of divisions with the time base to obtain time period. Now, the time base value, which would be obtaining from the time base knob, represents the time for one entire division. So if you know the number of divisions that completely fits an entire wave, you can multiply it with the time base to find the time period of that particular wave. Once you determine the time period, now you can easily calculate the frequency using the formula frequency is equals to 1 over time period. Alright, I hope you have understood this question. You should always expect an experimental type question in paper 2. These are really common, and I would suggest you to revise all the experimental type question in the previous years so that you can be confident in writing the answers of this type of questions. Okay, moving ahead. The diagram shows an oscilloscope screen. As you can see, this is mainly a segment of the oscilloscope screen. Um, they have also provided us the oscilloscope settings. Okay, so x direction 1 square, which means one deviation represents 0.5 milliseconds, and y direction 1 square represents 0.5 volt. Now, initially, the diagram was provided like this. It didn't have the red line. I basically drew the red line. Now, the first part of this question asks us to estimate the period in milliseconds of the wave. Now, when you see the word estimate, that basically means that you don't have to find a value accurately. The value of this answer would be in a particular range. So you just have to estimate correctly. Now, this was the initial scenario of the oscilloscope screen. They didn't provide us the equilibrium position. So what I did is that first I identified the equilibrium position. You will also have to do that. And once you identify the equilibrium position, now you just count the number of squares or the number of divisions that fits an entire wave. Now, if you carefully look at this diagram, it's a bit difficult in order to identify how many boxes basically fit a complete wave. For example, if you see this wave, if you consider this wave, which basically starts off from this point and ends at this point, you know that there are about 1, 2, 3, 4, 5 complete divisions which fit this entire wave. But you also know that this part also consists, or this part is of this thing, this segment is also a part which fits the wave, but you don't know how much this segment is. So in these situations, we usually estimate that this is, let's say, 60% or let's say 70% of the entire length. So what I actually did is that I basically calculated or determined the time period for two complete waves. That means I considered this wave and this one again. Now, if I count the number of boxes in between, you see that there are two segments which are incompletely filled. One is this part and the other is this one. Let's count the number of boxes in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that there are 10 boxes. We are sure of that there are 10 boxes which completely fit these two waves, but we will have to include this segment and this segment as well. If you look carefully, uh, if you add these two segments, that can be equivalent to an entire square, and that's what I estimated. What I estimated is that if I add this segment with this one, I mainly get an entire square, which means there are 10 squares already. I added another square, which makes 11 squares. So I estimated that there are 11 squares which completely fit these two waves. And that's why I multiplied 11 with 0.5 milliseconds in order to determine the time period for two waves. And then I divided by 2 in order to obtain the time period for one wave. So this is just one type of estimation that I did. What you can actually do is that you can you can basically count the number of boxes for one complete wave. For example, here we have got 1, 2, 3, 4, 5. We already know that there are 5 boxes, and you can consider this to be like 60% of this entire box. So at that time, that would be like 1, 2, 3, 4, 5, 5 plus 0.6, which is like 5.6 boxes for an entire wave. So at the time, you can multiply 5.6 with 0.5 milliseconds in order to obtain the time period for one complete wave. How I did is that by considering two complete cycles, I basically counted or determined the number of boxes for two complete cycles. And I considered this segment and this segment makes an entire square. That's why I considered 11 squares. So that's how you make estimations in this type of questions. And luckily, in this kind of questions, you will be provided with a range of answer in the mark scheme. So you don't have to be extremely accurate in this type of questions. All right. The last question: calculate the frequency of the wave. So once you know the time period, you just use the formula for frequency, which is 1 over time period, and you calculate the frequency. That's how you do it. I hope you have understood this question. If you have any problems, don't forget to write them down in the comment section. All right, let's see what we have in the fifth question. Question number 5a. The diagram shows a cross section of a solenoid. So this is basically the cross section of the solenoid, as you can see. This is mainly the cross section of the solenoid. Now the first question is, draw one field line on the diagram to show the direction of the magnetic field. So we will have to determine the direction of the magnetic field of the solenoid. Now we have been just provided with dots and crosses. Now what these dots and crosses represent? Cross basically represents current into the paper and dots represent current out of the paper. Now in order to determine the direction of the magnetic field around the solenoid, we will have to use the right hand grip tool. Wrap your right hand around the coil so your fingers curl in the direction of the conventional current from positive to negative, and your extended thumb will point to the solenoid north pole. So what you have to do is that you will have to curl the fingers of your right hand in accordance to the direction of the current. The crosses represent that the current is getting into the paper, and the dots represent that current is getting out of the paper. Now, if you can place the fingers of your right hand accordingly, the direction of your thumb will basically represent the direction of the North Pole. And this has been clearly depicted using this diagram. You can see that how the fingers have been placed in accordance to the direction of the current. So if you can do that over here as well, if you can visualize that thing and you curl up your fingers accordingly to the direction of the current, the thumb will basically point to the solenoid's North Pole. Now they have asked us to show the direction of the magnetic field. We will have to draw one field line. Now the magnetic field around this solenoid looks something like this. There are multiple magnetic field lines, but they just told us to draw only one particular magnetic field line. And I chose to draw the straight line which is in between these two segments, and I actually drew the direction pointing towards the left because when I use the right hand grip tool, my thumb basically uh, uh, my thumb basically points to this direction, which means we have got the north pole over here, and so the opposite one would be the south pole. And we know that in a magnetic field, the magnetic field direction is always towards the north pole, and it is always away from the south pole. All right. Use the field line to determine which end of the solenoid is north pole and label this on the diagram. So since this direction is the magnetic field line is towards this direction, magnetic field lines are always directed towards the north pole and is directed away from the south pole. And hence this one will be the north pole and this one will be the south pole. Okay. A transformer consists of two solenoids and an iron core. This is the level on the transformer. Number of turns in the primary coil 180, number of turns in the secondary coil is 345, and output voltage is 230 volt, output power is 320 watt. Set the formula linking input primary voltage, output secondary voltage, and turns ratio. So we will have to keep this one memorized as well. That is, primary voltage over secondary voltage is equals to number of turns in the primary coil over number of turns in the secondary coil. Or you can write the formula in terms of input voltage or output voltage as well. That represents the same thing as voltage in the primary coil over voltage in the secondary coil. Because the voltage in the primary coil is basically the input voltage and voltage in the secondary coil is mainly the output voltage. So you will have to remember this equation. Calculate the input voltage of this transformer. So we will have to calculate the input voltage of this transformer. We have been provided with the number of turns in the primary coil, number of turns in the secondary coil, and the output voltage. So you just substitute these values into this particular relationship and you make input voltage a subject. If you do so, you basically get a value of 120 volt. Now give the name of this type of transformer. The input voltage is 120 volts and the output voltage mainly 230 volts. As you can see that the voltage has been increased, which means this must be a step-up transformer. The last question, when the transformer is in use, there is a current in the primary coils and in the secondary coil. So the type of current in the coils of the transformer. Always remember that there is always an alternating current in the coils of a transformer. A transformer can only work when there is an alternating current in its coil. It can't work with the DC. It can only work with AC. So the type of the current will be alternating. Alright, I hope you have understood this question as well. Alright, let's look at question number 6. Galaxies A, B, and C are different distances from the Earth. Okay, Galaxy A is moving away from the Earth with a velocity of 1.7 into 10 to the power 4 kilometers per second. The reference wavelength for light arriving at the Earth for Galaxy A is 506 nanometers. So this wavelength is basically the laboratory wavelength, which is mainly the lambda naught. Okay. Calculate the observed wavelength for the light arriving from Galaxy A. So we will have to calculate the observed wavelength. Obviously, the observed wavelength is going to be longer than 506 nanometer because it is moving away from the Earth. So we will be calculating the change in wavelength at first, and we're going to add that value with 506 nanometer in order to obtain the in order to obtain the observed wavelength. Since the galaxy is moving away from Earth due to Doppler effect, the wavelength of the light arriving at the Earth would be greater than the reference wavelength, which is 506 nanometer. So in order to calculate the change in wavelength, we will be using the formula lambda minus lambda naught over lambda naught is equals to v by c, or del lambda over lambda naught is equals to v by c. I've written the entire equation in words as well. Change in wavelength over reference wavelength is equals to speed of galaxy A over speed of light. So you just have to make the change in wavelength or del lambda the subject, which is 28.7, and you just add 28.7 with 506. And I rounded it off to 535 nanometer, and this is mainly the wavelength which is being received on Earth from galaxy A. Alright, now galaxy B is twice as far from the Earth as galaxy A is from the Earth. Galaxy B is twice as far from the Earth as galaxy A is from the Earth. Galaxy C is 4 times as far from the Earth as galaxy A is from the Earth. Explain how the velocities of galaxies B and C are different. Alright, so we will have to compare how the velocities of galaxies B and C are different. Now, we know that the restriction of velocity is mainly proportional to distance, according to the Hubble's law, which is V is equals to H not D. I hope you are not familiar with this equation, but I hope you obviously know the Hubble's law, which is the restriction of velocity is proportional to distance. So the greater the distance, the greater the velocity. Now, we have been told that galaxy B is twice as far away from the Earth as galaxy A is, and galaxy C is 4 times as far away from the Earth than galaxy A is from Earth. So if B is twice as far from the Earth than A, then galaxy B has twice the velocity than that of galaxy A. Since it is twice as far from the Earth as galaxy A, so the velocity, the residual velocity of galaxy A, the residual velocity of galaxy B would be twice the residual velocity of galaxy A, since it is twice as far from the Earth than galaxy A. And then again, galaxy C would have 4 times the residual velocity of galaxy A, because galaxy C is mainly 4 times further from galaxy A. You can write the last statement as well, which is C is twice as fast as B. C is twice as fast as B, because if B is twice as far from A and C is 4 times as far from A, then obviously C is twice as far as B. So if C is twice as far as B, then the residual velocity of C is twice as the residual velocity of B. So if you write the first statement and the second statement, you get 2 marks obviously. And if you write the first statement and the last statement, you also score 2 marks. But the first statement must be written. That's compulsory. And out of the next 2 statements, you can write any one of them. All right. The universe started with an event called the Big Bang. Okay. Explain how evidence from the cosmic microwave background radiation shows the temperature of the universe has changed since the Big Bang. So you will have to memorize this theory as well. Now, what basically happened after the Big Bang is that the universe got cooled. Now, cosmic microwave background radiation basically proves us this thing, because initially, when the Big Bang happened, when the event occurred at the time, the waves that were emitted had got a very high frequency. But since the universe expanded, the wavelength of the waves emitted got increased as well. And now it is emitting microwaves. So wavelength of CMB has decreased over time as the universe has expanded. So this should be increased instead of decreased. All right. This suggests that the universe was hotter before and it cooled down gradually after the Big Bang. All right. So yeah, that were the 3 questions of question number 6. I hope you have understood question number 6 completely. Question number 7. A student investigates how the temperature of a metal block varies with time as it is being heated. Okay, student measures the temperature of the block at 5-minute intervals for a total of 30 minutes. The graph shows the student's results. All right, so let's have a look at the result. Let's have a look at the graph. We have got temperature on the y-axis and we have got time in minutes on the x-axis. So what the student basically did is that he heated a metal block and he recorded the temperature at 5-minute intervals. First question, give the name of a piece of equipment that the student could use to measure the time during the investigation. We can use a stopwatch or a timer. All right. Which of these is a dependent variable in this investigation? Okay. So any variable on the y-axis is basically the dependent variable, and any variable on the x-axis is basically the independent variable. Dependent variable is always on the y-axis and independent variable is always on the x-axis. So technically, temperature would be the answer to this question. So we were provided with multiple options, but yeah, answering this type of questions is really easy because we can easily deduce the answers from the graph. Okay, the energy supplied to the block is 440,000 joules. Calculate the mass of the metal block when the temperature of the block increases from 45 to its melting point of 450. For the metal, specific heat capacity is 910 joules per kg degree Celsius. So we will have to calculate the mass of the metal block. Now, in order to do this calculation, we will have to use the formula del E is equals to mc del T, where del E basically stands for the energy transfer, m stands for the mass of the object, c stands for specific heat capacity, and del T stands for change in temperature. So we know the energy supplied, we basically know the specific heat capacity, which is C, and we do know the change in temperature. That means we will have to calculate the change in temperature, which would be 450 minus 45. So we just have to make m the subject. We know the value for del T, we know the value for del E, we also know the value for C. So substituting them in the equation above and making mass a subject will give us a value of 1.2 kg. We will have to make sure the answer to this question is to two significant figures because all the figures used are in two significant figures. Moving ahead, we have got the metal block melts and then the liquid metal boils to become a gas. Describe the motion of the particles when the metal is a gas. So you will have to memorize this thing as well. In a gas, the particles are randomly arranged and they are moving randomly in all directions at very high speeds. The particles move randomly at high speeds in all directions. So in this single sentence, we have got 2 points. First is they are randomly moving at high speeds. The first mark is for writing high speeds. The second mark is for writing randomly in all directions. All right. So you will have to memorize this fact. You will also have to memorize the motion of particles in solid and in liquid state as well. For example, in solid, the particles vibrate about their fixed positions. In liquid, the particles slide off past each other. Okay. Now the last question suggests two changes to the graph if the student had used a different metal in the investigation. So if the student had used a different metal in the investigation, obviously a different metal would have a different specific heat capacity. Now, if objects have got different specific heat capacities, the rate of increase of the temperature of objects would be different as well because specific heat capacity means the amount of energy that is needed to raise the temperature of a 1 kg substance by 1 degree Celsius. So if objects have got different specific heat capacities, that basically mean that in order to raise the temperature of a 1 kg of that particular substance by 1 degree Celsius, you will have to provide different amounts of heat energy. Or in other words, in order to raise the temperature of that particular object or of that particular substance, you will have to provide different amounts of energies. And hence, the increase of temperatures would be different as well. So the first point would be the graph would have a different slope as temperature rises at different rates. Since the different metal would have a different specific heat capacity, it would require different amounts of energy to raise its temperature. So as a result, there would be the temperature rises would be different compared to the one that had been shown over here. All right, I hope you have understood this one. The second point would be their melting point would be different. That is, the graph levels off at a different point. So since we will be using a different metal, it would obviously have a different melting point, and so the graph would level off at a different temperature. For example, this one levels off at 450 degrees Celsius. The different metal would have a different melting temperature, and so it would level off at a lower temperature or at a higher temperature compared to 450 degrees Celsius. So that would be the two changes that will be brought to the graph. I hope you have understood both of the points and you have understood all the different parts of this particular question. The last question of this paper, which is basically from nuclear physics. The photograph shows a nuclear power station. So this is mainly a nuclear power station. A chain reaction releases energy inside the power station. Explain how the fission of uranium-235 can set up a chain reaction. So we basically know that in nuclear power stations, uranium-235 is basically used in a chain reaction in order to release energy, which is then basically used to turn turbines, which basically generates electricity. Now we have been asked how fission of uranium-235 can set up a chain reaction. This question is really common, and this is obviously a repetitive question. So you should have the answer of this question memorized. At the same time, you should also understand how the thing basically works. So in uranium-235, what basically happens in the nuclear reactor is that uranium-235 at first accepts a neutron. Uranium-235 absorbs a neutron, and as a result, it becomes unstable, uranium-236. So uranium-236 is basically unstable. Uranium-235 absorbs a neutron, and it gets converted into uranium-236, which is actually unstable. Now, uranium-236, as a result, splits, producing smaller nuclei and more neutrons. And neutrons. All right. So uranium-236 splits, producing smaller nuclei and more neutrons. Now, these neutrons are further absorbed by other uranium-235 nuclei, which then become uranium-236 and then release more smaller nuclei and more neutrons, which are then further absorbed by other uranium-235 nuclei. And the process repeats. That is how a chain reaction is being developed inside a nuclear reactor, and that is mainly the source of immense amount of energy which is basically produced from nuclear power stations. So a pictorial representation of the chain reaction has been shown over here. As you can see that first of all the uranium-235 absorbs a neutron, and then it becomes uranium-236, which is unstable, and then it gets decayed into smaller nuclei and neutrons and also gamma radiation, which has been released because energy is also being emitted. Now, these neutrons are then further absorbed by more uranium-235, which then become uranium-236, and then the uranium-236 decays to form more smaller nuclei and neutrons, and the process repeats. All right. Explain how nuclear fusion is different from radioactive decay. Well, in a nuclear fusion, we basically obtain a larger nucleus from a smaller nuclei, whereas in a radioactive decay, a larger nucleus basically gets split into smaller nuclei. So fusion is the joining of smaller nuclei to form a large nucleus, whereas in radioactive decay, a large unstable nucleus decays to form a smaller, more stable nucleus. All right. An isotope of hydrogen is used as a fuel for nuclear fusion. The nuclear equation shows how this isotope of hydrogen can be manufactured. Complete the equation by giving the missing information. So we will have to fill up a nuclear equation. Initially, it was something like this. Let me show you. All right. So initially, we were provided with this equation, with this incomplete equation. We will have to put numbers on this one and on this box as well. Now, in completing nuclear equations, you will have to make sure that the number of protons on the right hand side equals the number of protons on the left hand side. Also, the number of neutrons on the right hand side equals the number of neutrons on the left hand side. Or in other words, you can say that we should ensure the mass number on both sides are equal. Okay, now if you carefully observe, the total mass number on the left hand side is basically 7, which is 6 plus 1, 7. And hence the total mass number on the right hand side should be 7 as well. We have got 4 over here, so 7 minus 4 equals 3. So we will have to place 3 over here. All right. And we know that neutron has got no charge, and so we will have to place a 0 over here. Or you can also consider this in this way. We have got 3 protons on the right hand side, and we already have got 3 protons on lithium. If I subtract 3 from 3, we get 0. And so we will have to place 0 over here. We must place 0 over here in order to complete this nuclear equation. D. Explain why nuclear fusion can only happen at high temperatures and pressures. You see, in a nuclear fission, we will have to bring two nuclei together. Now, nuclei are positively charged because nucleus contains protons. So, bringing two nucleus is very difficult because they repel each other, and hence high temperature is required so that they have got very high kinetic energies. As a result of that, we will be able to overcome the repulsive forces between the two nuclei, and we will be able to bring them closer. Now, high pressure is also needed in order to bring the nuclei closer and to maintain a high fusion rate. So, if we maintain a high fusion rate, at the time, immense amount of heat energy would be released, and as a result, high temperature would be maintained and fusion would be maintained all the time. High temperature is needed to overcome the repulsive forces between the nuclei and so to bring them closer. High pressure is required to maintain a high collision rate. All right. Which of these is the time taken for the number of undecayed nuclei in a radioactive isotope to halve? So that mainly refers to half-life. The time taken for the number of undecayed nuclei in a radioactive isotope to halve is basically the half-life. It is basically the definition of half-life. They have just jotted down the definition of half-life. Okay, so just choose half-life from these options. The last question is basically a calculation as well. This type of hydrogen is radioactive and has a half-life of 12 years. A sample of the isotope has an activity of 72 kilobecquerels. Calculate the activity of the isotope in the sample after 60 years. So we will have to calculate the activity of this isotope after 60 years. We know that the half-life is 12 years, which means the activity of this particular radioactive sample gets halved every 12 years. And now we will have to calculate the activity of the isotope after 60 years. So we know that after 12 years, the activity gets halved. Now we will have to determine how many half-lives are there in 60 years. So we're going to divide 60 by 12. If we divide 60 by 12, we see that we have got 5 half-lives. So total number of half-lives in 60 years is basically 5. So you just have to multiply 72 with 0.5 to the power 5 in order to obtain the activity of that particular isotope after 60 years. You can also do the entire calculation manually. That means instead of just multiplying it with 0.5 to the power 5, you can just halve it 5 times and you still obtain 2.25. So yeah, that's basically the answer to this question, which is 2.25 kilobecquerels. And with that, we are basically done with the paper. I hope you have understood each and every question. If you find difficulties in any of the questions, don't hesitate to write them down in the comment section below. You can also inbox me personally. And I hope you have enjoyed watching this entire video. I hope this video helps you in your exams. Goodbye.